The W1045 is made of A36 steel and is used as a column that has a length of 15 feet. If the column ends are fixed at both sides, can the column support the critical load without yielding? So we've gone and looked up on a table what the stats for a W1045 beam are. And the area is 13.3 inches, and since it's fixed at both ends, we only pulled up what the least moment of inertia is, and in this case, the least moment of inertia would be 53.4 inches to the fourth. And so it's A36 steel, modulus of elasticity of 29,000 KSI, and a yield strength of 36,000 PSI. So we need to know, can it support the critical load without yielding? So let's find out what the critical load is. So we got P crit is pi squared EI over the effective length squared. So pi squared 29,000 KSI would be 29 million PSI. And our least moment of inertia is 53.4 inches to the fourth. Our column is 15 foot tall. It is fixed at both ends, which is a K value of 1/2. And we need to convert that 12 inches into 1 foot. And then we'll take that entire thing and square it. And this will give us a critical load, if you plug these numbers in, of 1,886.92 kips. So that's a lot. So 888.6. So that's basically 1.9 million pounds of force. So that's the critical stress. Question asked: can it support the critical stress without yielding? And as you just saw, that my laptop can't finish this problem without charging, so I've taken care of that. Let's find out what the critical stress is. So our critical stress is going to be what? It's going to be our critical load divided by the area. 1886.92 kip. We're going to divide that by 13.3 inches squared. And so that will give us a critical load of 141.87 KSI. Which, now the question is that less than the yielding stress, which is 36,000 KSI? That is not the case. This beam cannot support the critical load before the material will fail. So once we hit 36 KSI of stress, the material will fail. So basically, in this case, Euler's equation is not valid because the critical stress is higher than the yield stress.